welcome to my channel. This is your Rosie, and today in our Rose Maths, I welcome you. Welcome. And today we'll be looking at quadratic graphs and the interpretations. Okay, so sit back, get your pen and paper as usual, and let's do this together. I want you to pay attention and listen attentively. Okay, you are again welcome again to my channel. So we look at quadratic graphs and the interpretation. Before we go into the graph, I want to take you back to the general form of quadratic equation. Okay, here is the general form of quadratic equation. We have the ax squared plus bx plus c equals 0. And remember, your a should not be equal to 0. If a is equal to 0, it is no longer a quadratic equation. Okay, and then your b and c are real numbers. Okay, remember a, b, c are constants. Should know that. And then a is the coefficient of our x squared, which is the quadratic term. And then b is the coefficient of x, which is the linear term. And then c is the constant term. Okay, so get the general form of the quadratic equation down, and then we'll be referring to it as we go on and on. Okay, so let's identify these coefficients in a given quadratic equation. Okay, assuming this quadratic equation is given where you have your 2x squared plus 3x and plus 1 equals 0. Here your quadratic coefficient, which is a, is 2, and your linear coefficient, which is b, is 3, and your constant sign, which is c, is 1. Okay, so you need to know which one is a, which one is b, and which one is c. Your quadratic coefficient is your a, which is the coefficient of x squared. Okay, and that is 2 in this given equation. The linear coefficient is the coefficient of x, and here we have it as 3, and that is your b. The constant term is the free term, which is c, and we have it as what? 0. And remember, the right hand side of the equation must be equal to 0. Okay, so let's look at another example. Now, if you look at this, we have x squared minus 43x minus 728 equals 0. Now, there is no number before x squared, which is our quadratic term. So when you don't have any number before your term, it means that it is 1. Like I'm having it here now. So it is 1. So here our coefficient of x squared is 1. So our a is 1. Then our b is minus. If you have a negative, recognize the negative. Okay, and then the constant term is also negative, minus 728. And remember, this right hand side must be what? 0. Is that clear? So with that, I want you to try this out. Take a few minutes and give me your answer. Drop it down in the comment section. And as you're doing that, let me just give you what I have here. The quadratic coefficient is 2, and the linear coefficient is minus 2. Remember the negative there, and the constant term is minus 4. If this is what you have, you are correct. Alright, so let's move ahead to the graph. So here I have my graph board. Isn't it beautiful? Alright, so this is my graph board, and you can see I already have my vertical line and my horizontal line on the graph board. here is my x-axis, and here the vertical is my y. Okay, so on this I'm having my quadrants. So here is my first quadrant. Okay, on the first quadrant my x is positive. Okay, and my y is as well positive. So whenever I have my two coordinates, my xy coordinates, positive, positive, I should be looking at my points on this first quadrant. Now on the second quadrant, we go anti-clockwise. On the second quadrant, I have my x negative and my y positive. Okay, so in this, whenever I have x coordinate negative and y coordinate positive, then your point should be on the second quadrant. Here is my third quadrant. On this third quadrant, both x, y coordinates are negative, negative. Is that clear? So here is our fourth quadrant. On the fourth quadrant, x is positive and y is negative. So it helps you to know where your point lies. Okay, so with that, let's fix the points now. So points on a graph. Now I want you to pay attention. I want us to put our x is here and here is our y axis. Now let's assume that this is my point A. Point A, my x is 2 and my y is 3. So here is my y. So I'm having positive, positive. You can see it on the first quadrant. You don't need to be putting this first quadrant. Okay, just know that your positive is on this side. So my x is positive, my y is positive. You can see the point on x equals 2, and by the side I have y equals 3. Now the point should be where the two intersect, where the two meet. Okay, so that is where the point should be. Exactly. Now this is my point B. My x is -6 and my y is 7. So you can see the point. If you trace it down, you will see it on -6 and sideways is on 7. So y is 7 and x is -6. So this is another point. Let's call it point C. The point is at -8. So, and if you trace it to y, you will see that it is at 0. This is where y and x are 0. That's the origin, the point of intersection of the two x and y axis. So this is it. So here this point is at x equals -8 and then y is 0. So this is our point D. Trace it up to x as it is -6. So this is x -6. Trace it towards the y axis. It is -5. Hope you're getting what I'm doing. So this is another point. Let's call it point E. Yeah, our x here is 0. If you trace it up, you see it's at 0. And our y is -3. So this is it. So the last but not the least, let's call it F. So this is x and here is y. Now if you trace it up to x, you have +7 and sideways to y, we have our minus, so 7. So this is how you can put your points on your graph. Okay, so try it over and over. If you have any question, just drop it on the comment section and I will attend to it as soon as possible. So we'll move on to the quadratic graph itself. Now you have two ways your quadratic graph can look at. You can have a concave up, you can have a concave down. So the parabola, you can have the concave up, you can have the concave down. Now if you have the concave up, remember our general form of quadratic equation which I gave you initially, ax squared plus bx plus c equals 0. These are general form. If you have the concave up, it means that your a is positive. Okay, that you have a positive value of a in the equation. If you have the concave down, like we have it here, it tells that your a is negative. Okay, that a is negative. Now if you look at this curve, we have the y-intercept. The y-intercept is a point when x is equals 0. And then for this one, the y-intercept is the same as the vertex. The vertex, if you have the concave up, is your minimum point or your turning point. Minimum point or the turning point. At this point, you have the minimum value for your y. Okay, this is where you have the minimum value for your y. Okay, then we have the points. We have where the curve will cut your x-axis. So that point we call it the x-intercept. The x-intercept is where you have your y to be 0. At this point, y is 0. Okay, it's also referred to as the roots. Okay, the roots of the equation. That's where you get the roots of the equation. So it's either we call it the x-intercept or the roots of the equation. So the same thing here. So here we have our y-intercept. Okay, here is our vertex. When you have the concave down, your vertex becomes the maximum point. Becomes the maximum point where you have the maximum value for y. Okay, so let's look at an example now. So here is our example. Now if you look at this, this is where we have our y-intercept. This is where the curve cuts. This is y. Okay, and here is x. So here is our y-intercept. So here our x is 0 and our y is 3. Remember I said at y-intercept the value of x is always 0. So this is our y-intercept and here is our x-intercept. And here again is our x-intercept. And I said it is also referred to as the roots. The roots of the quadratic equation. The solution to the quadratic equation lies here. Okay, and at this point your y is always 0. And see our y at the 2 points are 0. X is 1 here and x is 3 here, but y is always 0. So here we have our vertex. And because we are having our concave up, we are talking about the minimum points here. The minimum points, and here you will talk about the minimum value for our y. And the minimum value, if you trace it, you will see that it is y equals minus 1. Okay, with this x-intercepts, we can get the equation of this quadratic curve. So how do we do that? We take the values of x here. So let me do it somewhere here. It will be x minus the first x-intercept. We have our x to be 1 minus 1. We close the brackets. Open another one, put x. So what's the value of x at the second? Is 3. So it's minus 3. Okay. Or equals 0. You now expand, multiply, you have x squared. Multiply, you have minus 3. Multiply, you have minus 3x, minus x, then you multiply, you have plus 3, all equals 0, giving you x squared minus 4x plus 3 equals 0. So this is the quadratic equation that gave birth to this quadratic curve. So x squared minus 4x plus 3 equals 0 is the quadratic equation for this quadratic curve. So actually you can use the quadratic curve to, get the quadratic equation if the quadratic equation is not given. Now we know the roots. The root is the point where x is 1 and 3. Remember, it's also referred to as x-intercept because at this junction, the value of your y is 0. Okay? If you have any question, drop it in the comment section. I will attend to it as soon as possible. So move over to the next graph we have. Here we have the concave down graph. So, and this graph here is our y-intercept. Our y-intercept, and also is our y-intercept and also our vertex. And because it is concave down, we'll be talking about the maximum point. Okay, we'll talk about the maximum point. Here we will get the maximum value for our y. And here the maximum value is what? 2. Is that clear? So at this junction, we have our x0 and our y2. Okay? So here we have our x-intercept. And at this junction again, we have our x-intercept. Now between here to here, let's say 1 cm here is, remember we're not talking about scale, but from here to here is 2. And if you look in between, we have 1, 2, 3, 4 lines. So if I'm to tell what is here, all I need to do is to divide this 2 by the 4 lines so that I'll get the value for these single lines, which gives me 1 over 2 and 0.5. That is half. So here is half, 0.5, If I add another half to it, meaning that here is 1, and also here it will be minus 1. So at this junction, the roots here, the coordinate I have at this root is minus 1, 0, and at this also I will have 1, 0. Okay, so that's the coordinate at this x-intercept. Remember, your y is 0, and the same here. But the value of x here is minus 1, and the value of x here is 1. So the root here is minus 1, and the root here is 1. So try it out. If you have any questions, drop it in the comment section. So this is how we can go with the quadratic graph and the interpretations. If you have any question, just drop it at the comment section and I will attend to it. Thank you so much for listening, and God bless you. Bye bye.